This conference will now be recorded.
Hi, good morning, good afternoon, everyone. Welcome to the first staff meeting of 2022. Happy New Year, everyone. It's been two weeks or so since we last have spoken, and so we have a full agenda today. We will start off with some updates about our work that we're doing under TAP, and then we'll hand over to discuss a very interesting subject that we have not paid a lot of attention to recently, and that's challenges in antennas in getting those GNSS receivers we talk all of the time about to work and sync with the outside world. So let's dive right through. So that's this. This one will be our 38th meeting. It's been more than a year that we're working on this project, trying to bring in the different ideas and concepts required to accelerate adoption of time in data centers. And for that, we have announced a couple of new work streams in our last OCP Global Summit, and we have now 7 working work streams dedicated to different aspects of delivering time. With us today is Georgi, who is leading the work stream number 3, Precision Time APIs. And Georgi, I would like to hand it over to you for a quick update.
Thank you, Elad. Can I share my screen?
Sure, let me do that. I'm giving you the access as a presenter.
Hello, I'm Georgi Chelakov, and this is going to be a very short announcement. A month ago, I had a presentation about the value of discussing how we can improve the time API. There was a few missing pieces, but now we have everything set up, and it's about time to start getting together and discussing how we can do this better. The time API and the proposal for improving our ability to utilize the time that's on the machine from the user space so we can build better systems, better services. I'd like to show you how you can register in the email list, so you can participate in the discussions. We are coming from different time zones, and I assume the asynchronous work can be really our main way to communicate ideas and discuss. So if you go to the Time Appliance project, this is Open Compute Wiki Time Appliance project. You go to the 3rd project, Precise Time API. We have a wiki page with short description, and on the very bottom you have a mailing list. If you are interested to discuss how we can improve the time API, please join the mailing list. We'll have a short discussion, find what is the best time to get together, and start having regular virtual meetings. That's all. Thank you.
Thank you, Georgi. We have put in the chat box the link to the wiki page and the link to the mailing list. So for the interested folks, please subscribe, and that would be the best means of communicating the progress over this work stream and other work streams. So click right through and join us in this upcoming work on APIs and the rest of the groups as well. Right, up next, I would like to introduce our speakers for today. So they come from PCTEL, and they're going to talk about, well, I'll be reading that. One of the most overlooked and took for granted components in a timing synchronization system is the antenna. Most times in such a complex and convoluted system, the interface between the free space where the GPS signal is entering and the conversion into the electrical signal that is going to feed the complex GNSS circuits is assumed as a simple piece of the system. without considering all the potential risks that an antenna failure could create. We like to think that in many cases, the antenna is the weakest point of failure in a timing system. We'll go over anatomy of the antenna, how it works, and best practices on how to select an antenna and accessories from timing synchronization systems. So the speakers will be Daniel Laredo, who is the Vice President of Global Business Development at PCTEL, and Daniel Schuster, okay, Business Development Director, also with PCTEL. I'll give you now the floor, and you can introduce yourselves better than I did and dive us right through this topic. So Daniel Laredo, will you go first?
Sure, thank you, Alad. Hello, everybody. Pleasure to be here with all of you. I'm, as Alad said, I'm Daniel Laredo with PCTEL. I've been with the company for 18 years. We'll talk a little bit about PCTEL, but one of the things we look into is we specialize in antennas in general, and timing antennas in particular is one of the areas where we are mostly focused as well. So we'll go over the presentation. Please feel free to ask any questions, and we'll do our best to answer them. Daniel Schuster, you want to go?
Yeah, thank you, Daniel. I'm Daniel Schuster. I work for Daniel Laredo. We've been in the industry for quite a bit now, over 27 years in the making. We're a very stable company that has been leading the GNSS field for many years, thanks to all the innovation that we bring in. And we met your team a few months ago and felt that it was a great opportunity to contribute to all the open community that you guys are chairing and rooting for. And we believe that as we went through the material, there was something that we could contribute, which is, providing and educating on the understanding as to how critical the hardware side of everything that you guys do can be to make sure that you got the right timing synchronization. And I think without further ado, I would let Daniel lead us.
Yeah, thank you, Daniel. All right, so the topic here is you're probably going to end up the session knowing more about antennas than you ever wanted, and I apologize for that ahead of time. But I think it is an important topic. We've been in this business for quite some time, and that's why we wanted to bring it to your attention. Let's see, how do I go forward here? Okay, so before I start, going specifically into the subject, I don't want this to be a sales pitch or anything about, the company we work for, but I'd like to give you some background, to why are we here and who are we to talk about these things. And one of the things I like about this group here today is that it is in an area where we've worked for a long time, and many of you might be familiar with PCTEL, which is not something that happens often when we go to a place and we have to explain who we are and where we come from. And many of you know us. Some of you use our products already. Some of you have seen our products in different environments and in different applications. And PCTEL is, I believe, it is an authority in everything that has to do with antennas. GNSS antennas as well, and then GNSS timing antennas more specifically. We probably have today one of the broadest portfolios of options for GNSS timing antennas. We have a really rich R&D team that is continuously developing new products in this space. And then most importantly for us, it's also, of course, our customer base. We work directly with a lot of the companies that are doing timing and synchronization systems, whether it's ADVA or what used to be Symmetricom through all the different incarnations up to today, Meinberg in Germany as well, for example. And then we also work with in the telecom space with a lot of the OEMs. They adopt our antennas into their base station products every time they're going to do timing and synchronization applications, whether it's at a macro base station or a small cell base station, all different types of configurations. We work very closely with them. We work very closely with the mobile carriers worldwide for their timing antenna requirements. For example, here in the US, Verizon uses exclusively PCTEL antennas. You'll probably identify those with some of the pictures we're going to show later. But so many of the other carriers, and then in other spaces, whether it's on the utility space and power distribution and timing requirements for that, or whether it's on the fleet space, we have a very large install base of timing antennas across the world, and that's why we think that we have the knowledge and would like to share why we think. And yes, we're biased in terms of being able to, show the importance of antennas, but I think it's something that not a lot of people think about. So, why are we here? And we're glad to be here because this is a team that understands, timing and synchronization systems quite well. This is, you guys know how critical it is, the type of systems you have developed. The time card, I think it's a fantastic outcome of this collaboration between you guys. And I personally came across, I think it was a uBlocks article that I was reading, and that was the first time a few months back that I heard about it, and I thought, wow, this is a very interesting topic. This is something right up our alley that we would really be interested in. And then we went into the into your repositories and started looking at all the documentation and everything, and voila, nothing about the antenna. And it was a disappointment, but it was as expected. You guys are not the only ones that don't think too much about the antennas. Being on the as an antenna manufacturer, we experience this a lot of the times. OEMs, end users, integrators, everybody comes to us right at the end when they say, hey, I need an antenna. What do you have? Or how can you help us? Or can you design this for me? It has to be this way. And you have 2 or 3 months to do it, and hurry up, because we didn't think about that before. So it is common. People see the antennas as accessories, something that they'll take off the shelf, but it does require a little bit of effort. There is some science into the GNSS antennas. Not all GNSS antennas are made the same. There's huge differences. There are huge drawbacks of using the wrong antenna. I don't know how familiar you are with the space. When Ligado wanted to deploy their terrestrial network very close to the GNSS frequencies, the uproar that happened, and one of the reasons was because people were using, antennas that had very lax filtering, that were not guarding bands that they were assigned for, and that deploying a terrestrial network was going to cause huge problems and havoc in the telecom business, in the banking industry, everywhere, in the agricultural space, in the military, and all because for many years people have been using antennas that are okay. They're not the best, but who cares, because all those other frequencies around GPS and GNSS have always been guarded and not used until somebody decides to use them, and that causes a lot of problems. So we'll tell some anecdotes about that as well. So how important is really for timing and synchronization the GNSS system? Well, an intelligent man once said these words, and it is crucial in the timing system, right? It doesn't matter how great the rest of the components are, the atomic clock, the rest of the NIC card, all the GNSS receiver, you know, it's just, you need something to synchronize all the cards, all the appliances, all the devices at the same time. And you know, we have the great luck to be able to count with a system like GPS or Galileo, or you know, any GNSS system that provides timing worldwide. You know, I think that's you hear all these polls all the time. What is the best invention of the 20th century? What is the best invention for the 21st century? And everybody's like the plane or the rocket or the internet. And I always quietly think, you know, GPS should be up there somewhere. The flexibility and the capabilities that it provides, specifically on the timing side, that not so many people are aware, but all of you are very aware of. I think it's something that it is wonderful. You know, it's a service that it's available worldwide, and it's a service that it's free, pretty much. Unfortunately, it's a very vulnerable service, and should something happen to any of these systems, you know, we would be in quite a bit of pickle here. So, you know, you have your timing appliance, whether it's in a network interface card form factor, or whether it's a separate device. But you know, there's a lot of things that can happen for that to fail, and it happens all the time. You know, you talk to a wireless carrier that has thousands of these devices deployed, or other major users of, and they will tell you that yes, there's a lot of things that go on, and there's a lot of, you know, replacements and fixes that have to be done for this. But you know, they usually, people think about, well, at the component level, or you know, there's a power surge, or there's you know, something happens, but people really don't think about the antenna. And the antenna is, we call it really the weakest link, because you know, if you don't have reception of your GNSS signals, which can only be achieved through the antenna, then you're not going to be able to synchronize your device. And that, of course, defeats the whole purpose of what a timing device is intending to do. You probably know that, you know, GNSS signals, by the time they get to ground level here, they're extremely weak. In many cases, they are below noise floor, anywhere between minus 125 to minus 145 dBms of signal strength. They are extremely weak signals, susceptible to a lot of interference problems, you know, multipath issues, and dealing with that kind of low signal strength is a problem. GNSS receivers have gotten much better over the years. Their sensitivity has gone, they're much more sensitive. You know, today you can get up to you know, minus 150, minus 160 dBms of sensitivity, but in real life, you know, it's really around the minus 130 dBms. That once you get below that, you're going to still have issues. And of course, there are holdover systems, and there's other alternatives to complement timing temporarily, but you know, it is the weak link. If the antenna fails, eventually the system will fail. And there's a lot of ways that the antenna can fail. The antenna can fail mechanically. The antenna can fail electrically. The antenna can fail, you know, because of the elements. You can, you know, remember, in any timing system, you require an antenna. The antenna has to be outdoors. The antenna usually cannot be indoors. It's a problem if the antenna is indoors. By being outdoors is the only part of the system that is susceptible to the elements, that is susceptible to vandalism, that is susceptible to you know, all different kinds of you know, a lightning surge. So you know, it really, from an environmental point of view, from a mechanical point of view, it really puts it at risk, puts the whole system at risk. And there's a lot of things that people usually do to go around these issues, and you know, we'll talk about those shortly. So before we get there, you know, let's take a step back and look at the GNSS antenna. I'm not sure if you're familiar to what's inside a GPS antenna or GNSS antenna. It's not really that complicated, but it's not really that simple either. This is usually these are active antennas that contain the low noise amplifier inside. There's additional circuitry for voltage control. These are antennas that need to be fed from the receiver itself, certain voltage and current requirements depending on the antenna. It used to be in the old days, sometimes you would even need 24 volts to feed the antenna. Today we're more in the 3 to 5 volts, that it's a lot easier to supply even by smaller receivers and systems. But it's an active antenna. There's filtering, there's all kinds of circuitry in there. Sometimes the actually receiving element can be either a patch or a helix. We'll talk about that shortly. But today they're a lot more complex because there's more GNSS systems available. It's not just GPS like it used to be, but all the other constellations that are available today and providing timing as well. And then within each constellation, there's multiple bands that are available today. So where before it was an L1, E1, G1 band, today they're opening, the L5 band. The L2 can be used for many types of applications as well. So antennas are becoming more complex. GNSS receivers are becoming more accurate. The holy grail of in the positioning world of centimeter accuracy, it's getting closer and easier to achieve because of the multiple constellations of satellites, where before with GPS you would have 24 satellites, and sometimes you would see some, sometimes you would see others. Here, today, in today's world, there's a lot more to choose from and a lot more signals to play with and improve the accuracy of your systems. So, there is a lot here on the left-hand side. You can see some of the different types of components. I'm not going to go too much in detail, but there's quite a bit to be done. If you're using multi-band systems, then usually you achieve that by stacking ceramic patches, because they're usually not very wide band. So you're going to have at least 2 or sometimes even more patches to be able to have a broadband antenna. There are some different techniques, whether it's single feed or multi-feed, in order to provide a better multipath, better axial ratio. So on the right-hand side here of the presentation, you see all the different types of use cases that we usually see for these antennas, but also the requirements, right? So you have your mechanical requirements. Where is the antenna going to be placed? How is it going to be placed? What kind of materials needs to be made of? Plastics, metals, all these things, ground planes, all these things affect the performance of the antenna. And then on the electrical side, what kind of gain are you going to have on that LNA? In today's world, usually you have 25 to 28 dB gain antennas, but you also have variations that are high gain, which are up to 40 dB of gain. Of course, you can go higher, but that also brings some drawbacks in terms of interference, in terms of noise figures that for some of the applications are important, not so much for timing, but you have to take into account all different types. So what I'm trying to paint a picture here is it's not a trivial thing to do a GNSS antenna. It requires some intelligence. It requires some understanding of what the application is going to be. And you can design a good antenna to mitigate some of the typical problems that you'll encounter in timing applications. So just going really quick here, as I said, there are different types of receiving element. All these antennas, by the way, they're only receiving. They don't transmit anything. So in that sense, they're a little bit easier to design. They don't need any special certification like the receivers do. because this is just a receiving antenna. There's no radiation on it. Of course, we pass them through all different kinds of environmental tests, EMC testing as well. For Europe, they require the CE self-declared certification, and that requires that we do EMC certifications and things like that. But these are the different versions that you have. You can have a helix, you can have a patch. If you have patch, you can combine them and have access to multi-band, broader, wider band antennas. The benefits of a helix element is that it has a more omnidirectional pattern. So specifically at the low angles, with the patch, you have not the best coverage. So if you have satellites at the horizon, that might be a problem for the receiver to be able to decode properly. But if you use a helix element, that creates a much better radiation or receiving pattern. Usually in urban applications, in urban environments, helix performs slightly better. But again, it all depends as well in the location, in the position, in the installation of the antenna. Going through, and this is probably one of the most important slides here, going through the design requirements for antennas, the filtering, what we call the out-of-band rejection, is extremely important. This is something that we at PCTEL put a lot of care into. We have most of our antennas have a dual stage filter, but and some even have 3 stages and so on. And this is what I was talking before of how important this is, having a tight filter here, or as tight as you want to have it, to be able to filter signals and interference that is coming from out of band. You can see the blue trace here at the top. These are traditional antennas that you can pick up, thinking that they're great for your application, with very little filtering or no filtering at all, other than what the patch provides, which is not enough for timing applications or even for positioning applications, much less for survey and other types of applications of that nature. So we, the type of filters that we use, the flatness of the filter is quite important, and of course the rejection, the slope here at the sides, it's of great importance. Just a case in point, for example, over the last few years, 700 megahertz cellular systems have been coming up across the world, and it happens that the second harmonic of that system falls right, pretty close to the L1 band. So if you don't have the right filter, you could have an LTE system or a 5G system now interfering with your receiver without even knowing it. If you have a tight filter here, you could mitigate some of those problems. And here are some examples as well from us, of the different types of filters. Not every application requires a lot of filtering, but some do. And as we said before, the more filters we add makes it a better out-of-band rejection. But on the other hand, it increases the noise figure as well. And in some applications, that's not something that we're looking for. So, there are all different kinds of, so it is something we need to be aware of and be able to know how to choose. So how do you choose the right antenna? Well, from all that I've been saying so far, there are quite a bit of requirements. You have to understand not just what the antenna does, but how is it going to be placed, where is it going to be placed, how is it going to be installed, who's going to install it, what kind of gain do I need, what are the electrical requirements, what are what is the receiver that the antenna is going to connect to. If the receiver doesn't support multibands, then no need to put a multiband antenna. It's probably more expensive. Look at the rejection, look at the all the other electrical parameters, make sure it's compatible with the receiver that you're using. And then on the mechanical side, you have to make sure these are high quality, long lasting antennas. It is a critical system at the end of the day. You want to have something that it's reliable, that it has a MTBF of many, many years. You don't want to be changing antennas all the time. In many of these cases, the antenna is not easily accessible, so changing an antenna might be quite a bit of a problem. And then there's other things that we recommend. Verizon, for example, uses a diversity setup. So every time you see a macro station from Verizon, there are two antennas there. If one fails, you still have the other one. And then there are additional accessories that are important for this. So installation considerations, the basic ones, look for clear skies, no mechanical interference, no unobstructed views. Don't put it indoors. Don't put it even for in-building systems. There are many times that people are putting antennas close to the window, facing the outside. But in today's buildings, all this glass that it's used is metallized glass, and it really defeats the purpose of that. So having the antenna outside is the ideal scenario. In many cases, antennas end up in towers with other co-located antennas. That is a big problem. You have to be very careful where that antenna is being placed. Especially, what we said before, there are other RF interference sources. LTE at 700 could interfere, and it happens that all these antennas that are in towers are connected directly to RF equipment at high power. So it's not like in a building where you still can have interference, but at least you don't have a 100-watt transmitter next to the antenna. While in towers you do, so you have to be very careful when you're installing in towers. How do you do that? And then as I said before, easily accessible, but not that easy that people can come and vandalize it. We've seen that quite a bit in many scenarios. Believe it or not, these antennas, they're small relatively, but they still stand out, and some people like to shoot them. So use shotguns and things like that. We've seen a good amount of those in rural environments, and where people just like shooting things. So that antenna it's a great target as well. And then something that is very, very important is the surge protection. And the way surge protection works, and I'll show you some interesting pictures later, is in any other scenario, you have your antenna, there's a cable that connects to the antenna. At the end of that cable run, people put surge protection, and then that surge protection, there's a small cable that goes inside the building and protects the equipment. But that is the problem, right? It's only protecting the equipment, and in a timing system, the antenna needs to be protected as well. If the antenna is not protected against surge or lightning, then it's going to fail eventually. It could fail eventually, and if that happens, then the whole system again fails. So surge protection, when people and installers are really good at doing the surge protection for the equipment side, but are not really that aware of the surge protection on the antenna side, because most of the antennas they install are passive antennas. There's no, they're a piece of wire or a PCB inside, or elements that are passive. There's no electronics inside usually. So for any RF system out there where you see antennas, whether whatever it is, there's very little protection on the antenna, because the antenna doesn't need to be protected unless it gets hit by lightning, which in that case, there's nothing that's really going to protect the antenna. And it's the same thing with GPS timing. If we're not protecting the antenna not to be hit by lightning, that's highly unusual, might happen every once in a while. But the problem with lightning is if lightning falls close by, remember there's a cable run that goes from the antenna all the way to the timing equipment inside the building. That cable run can be anywhere from 10 meters to 100 meters. And if there's a lightning that falls close to the cable, it's going to create an electromagnetic field that's going to be picked up by the cable because it's a conductor. And that surge, it's going to drive both to the antenna and to the equipment inside the building. So if there's no surge protection, damage will eventually occur. So, you have to be careful. Surge protection is vital for timing systems. All surge protectors have some form of grounding as well. So you have to make sure that all parts of the system are grounded the same way they should be. And, there's all other different types of good practices for installers. When you put these cables connected to the antennas, you have to weatherize the connection. You have to protect it. You have to make sure it's waterproof for rain and snow and all those kind of things. Which actually brings me to another topic that I didn't talk before. The shape of the antennas. Why are timing antennas usually this way, and why you shouldn't be using flat antennas for timing applications? So it's pretty straightforward. These cone-shaped antennas help during winters. There's no ice is hard to form in this type of shape, so you won't have ice. If you have ice forming on the antenna, it's going to affect the, of course, the radon of the antenna, and it's going to probably detune the antenna. So it depends, how much snow and how it works. And then, of course, you also have birds, which is a problem. If you have a flat top antenna, birds can get on the antenna. They can do their necessities on top of the antenna, and we've seen that as well. Might sound with low probability, but those things happen. And here's an example. So there's this is a good setup of the antennas, the diversity. Maybe the two that are here together, it's not the best setup, but this defeats the purpose of the birds coming and being there. And this happens all the time. Birds find these setups quite amusing. And if you would have a flat antenna, the birds will stand on the flat antenna. It's not unheard of.
Hey, Daniel.
Yes.
I was looking for the right time to pass a question.
Yes.
So Jaime here is asking whether PCTEL has antennas that receive C-band signals.
Yes, we do. I'll be more than glad to talk about that offline and provide some options. If you go to our website, PCTEL.com, or also if you go to antenna.com, you'll be able to reach our portfolio and see some, not all, but some of the products that we have there.
Okay, thank you.
Thank you. So, I've talked about lightning quite a bit, and you might think, oh, come on, I mean, how much lightning is there? Really, is that really a problem? And, I challenge you that next time there's a storm around your place, go to lightningmaps.org. And that is a really interesting website where you can see real time all the lightning that is occurring across the US and also Europe. I've seen it, I've used it only in the US. So there's all these sensors that people buy and volunteer and place all over the geography. And then you can see real time how much lightning is happening. And believe me, it is 100 times more than what you think. I just took this screenshot yesterday or the day before, and small storm, not a big deal. And you can see that there's about 9.410 lightning incidences per minute. When there's a real thunderstorm, this number goes to anywhere between 100 and 500 lightnings per minute. Most of those are cloud to cloud, not cloud to ground, but still, you can sense that the electromagnetic field that it's out there is pretty heavy. The probability of lightning hitting somewhere where will create a surge that could affect the antenna is real. You have to believe me. Next time there's a thunderstorm, do go to this website, and you'll be surprised how many lightning strikes are happening around you. As I said, although we're in the wireless world, we need wires. There's a famous Dilbert cartoon that says, "Why is it called wireless if they have to be connected to a wire?" So and that's true. All these antennas, there's a cable that has to be connected from the antenna eventually to the GNSS receiver. And choosing that cable, even that small detail, is quite significant. Cables have losses. If you're going to put surge protectors in line as well, those provide some insertion loss that has to be taken into account. And usually in the literature, you can see that it's usually recommended not to use more than 100 meters of cables for GNSS applications. And even in those cases, 100 meters it might not be enough. We'll talk about that in a minute. But you can see that 100 meters, even if you use relatively good cable, you're going to be adding quite a bit of loss to the system. Remember, GNSS signals are being received at about minus 130 dBms on the ground. If you put a cable like a LMR 240, 100 meters, that's another 33 dB of loss. That's quite a lot. So maybe that's not what you want to do. Maybe you want to use a thicker cable. Of course, using thicker cables, they're less manageable in terms of guiding them through different holes and nicks and places. So it is something to be taken into account and to be considered. What cable do I use? What types of connectors do I use? You have to make sure that they are outdoor rated. You have to make sure that they're the connections are waterproof. You have to weatherize them anyway with cold shrink or other types of techniques there. So there's a whole installation issue there but it needs to be taken into account. And then what do you do when you need more than 100 meters? What if you have a really tall building, 20 floors, and you're going to put the antennas all the way on the rooftop, and you need, I don't know, 200 meters or more than that? Well, there are options. There are RF to optical converters out there in the market, which basically right after the antenna, you convert the RF signals to an optical signal. Then you can have a fiber optic of as long as you want, practically all the way routed to the place where you need it, and then you reconvert back the optical signal to RF signal. Then any delays or any of that you can compensate in the system usually, but these are expensive. There's two sides to it, and these are several thousands of dollars, and of course you need maintenance and you need quite a few other things. It complicates the system. So there are ways. It's very effective. One of our customers that you might be familiar, Mindberg, that does timing systems. They have their own system as well, their own antenna. I don't think it's optical in their case. It might be they modulate the signal to be able to transmit it over cables over longer distances, and then demodulate the signal to get what the original signal they were receiving. So there are different techniques, there are different ways of doing this, but it is expensive. You have to take that into account. So let's go back to the time card, and we talked about antennas. Probably again, it's more like you ever wanted to hear. But I think one of the reasons we're here is because we we appreciate the time card and what all of you have done to create this product. I think it's revolutionary in terms of the open project that it's been going on, and how you guys keep adding more features and more things, and you know, keep meeting and trying to improve this. I think it's something that the industry needed as well. So I think this is quite interesting. And I think, you know, it makes it affordable because you know, you're providing it as an open source project. But this is the time card, you know, with the way it is configured and the way that it's suggested, it's not cheap because it's a cheap card or because it's using cheap components. You guys are, you know, selected quite a bit of really good, reliable components, you know, whether it's the atomic clock or the GNSS receiver, or you know, the FPGA. These are high quality components. You know, there are GNSS receivers out there that are a fraction of what this one is, or I'm sure there are atomic clocks that are probably even cheaper. But you know, the reliability and the importance, the quality of the product is there. It's a high performance product with premium components. It is not a low cost product because it uses low cost components. It's a low cost product because you're cutting the middleman in many cases, pretty much, and you know, the software development, which is a huge part, it's being provided. So you know, bear that in mind when you use this in projects and you need a GNSS antenna, or people that you know, or your customers, or whoever is going to be using this, whoever is the end user. You know, it's going to defeat the purpose of having such a good product if you just take any antenna that you think it's available out there without, you know, doing it consciously and evaluating the product as it should. And then you're going to have, you know, great product with a very poor antenna that is going to affect and denigrate the performance of this product. So it's like having a really nice car with you know, bicycle tires or something like that, or really nice house with a very little door to go in. So you know, bear that in mind. Do not use a low-cost antenna. Of course, I'm biased, but you know, do yourself a favor and make sure that that's what you get. So I think I've talked quite a bit. You know, just to summarize this, pretty much everything that I've said before. Antennas, not a lot of people think about it all the time. We do, but you know, think of it. You know, take it into account. It's not trivial. It can make or break your overall system. You know, the type of product you've developed is amazing. Should be paired with a good quality antenna as well. And that's it for me. Any questions?
Yes, there is another question for you, Daniel. It's coming from Ali. So Ali is asking, do you envision the commercial market adopting multi-element CPRA systems in timing applications, maybe for safety critical applications?
Yeah, I mean, timing applications are all over the place. You know, if you're not in this industry, you really don't appreciate the system, right? You don't really feel how important it is. You know, whether it's communications, whether it's banking, whether it's electricity, you know, utilities. It's just so ingrained everywhere, and it needs to progress the same way positioning is progressing, right? With new constellations coming up, accuracy is improving. You know, so what effect is that going to have on timing? How is it going to be used? You know, when multi-constellation receivers were first launched, they were not really multi-constellations. They supported multiple constellations, but one at a time, or things like that. So you know, things are evolving. There are going to be you know, multi-band, multi-element systems all over the place, and you know, there are going to be more and more applications that are going to use timing, you know, in general. So I think there there's a lot to be done in terms of, making better use of multi-constellation systems. There's more to be done in improving or mitigating the vulnerability of GNSS systems. It's a huge problem. Interference, spoofing, all that. It's very it's a big problem, and it's a very delicate system. In today's world, there are many ways to disrupt GNSS systems. So, yeah. There's a lot of development in that space that needs to happen.
Ali, does that answer your question? Great. Let's see if there are more questions coming on the chat. If not, you can feel free to open your mic, video as well. So no more questions are coming. Thanks, Daniel from PCTEL. I think that was a great overview for antennas and the importance of that. We'll see a lot more of our time cards, right? And similar time card appliances coming either from this group or from like-minded products, and that definitely calls for a good match with the antennas. It will be interesting to see what you meant by price performance. So I don't want to it's not a commercial conversation right now, but with timing cards being available more broadly, then just one should assume what will happen to the antennas and what would be a good match to make that more available.
Yeah, I mean, just to give an indication, we're not talking here about hundreds of dollars for antennas, right? I mean, there are antennas for survey and positioning that can get very expensive, but I think for timing applications, we're talking anywhere, depending on volume, of course, but anywhere between the $50 to $100 range, just to give you an idea.
That's right.
Yeah, I mean, using $10 antennas, that I wouldn't do it. Using a $150 antenna, that might be also too much.
Well, thanks for the guidance. I think it's very encouraging.
Yeah. All right. Well, thanks again for having us, and we'll keep an eye here. We're really excited that for what you guys have done.
Thank you. Thank you, and thank you for your support, and thanks for reaching out. If you can share the slides with that, we'll place it on our wiki, and this way other communication could happen.
Yeah, we can definitely do that.
Ahmed, any closing words from you?
No, I think we have now Cliff.
I know he's going to join us the other time.
Okay, no problem. Yeah.
All right, so that's all for today.
Okay.
Thank you so much.
Thank you.
Thank you.
Thank you, everyone. Bye-bye.
Bye.